Well, this is kind of a supplementary presentation in the sense that we've already had a study of the previous six or the first six of the presentations around population studies as well as aging was in there. But this one is addressing hole in the heart. And from what I have heard from Stuart outside of this presentation is it's a wee bit alarming. So over to you, Stuart. Thank you.
Hi, Gary. Thanks for asking. Yeah, we want to talk about atrial septal defect, which you can call hole in the heart. This is the commonest of all the heart defects in babies, and heart defects in turn are the commonest defects in babies. So the biggest group of birth defects in children is heart defects, and the biggest group of heart defects is atrial septal defect. And this group of slides isn't all prettied up, but it's taken direct from a paper we've just written on this subject, which we hope will be out in the very near future. And that's the title of our paper. It's Supra-Exponentiating US Trend-Breaking Cannabinoid-Driven Atrial Septal Defect Trajectories as Key Epidemiological Bellwether Indices of Widespread Cannabinoid Genotoxicity. And I'll break that down for you to make that more understandable. This defect in places is rising faster than exponential. It's breaking the trends in that sense, driven by cannabinoids. And atrial septal defect is a key epidemiological bellwether index of widespread cannabinoid genotoxicity because they don't do early termination of pregnancy for this defect, whereas a lot of the other major defects, they do practice it. So in a sense, these numbers are as they are. It is what it is, right? So we don't have to make allowance. We don't have to guess what the ETO-PFA rate is because we know it's about zero here. So we can, and so the point is that what's happening with atrial septal defect may be a measure of what's happening more widely with birth defects across the gamut, across the spectrum.
So you're saying that there are less abortions likely for this particular condition because it is operable?
Yeah, virtually none for this condition. So the data is what the data is. There's no guessing at all. Now, this is the first paper to draw our attention to it, which is from Hawaii. As you can see, it says amongst prenatally exposed mothers, the rate of atrial septal defect was 6 times those who were not cannabis exposed. And the confidence interval is from 2 to 14, so it's a wide confidence interval. But the rate ratio there is 6-fold. And this is some powerful studies that were done in 1969, and they talk about in a large total dose, edema, phocomelia, omphalocele, spina bifida, anexioencephaly, multiple malformations, and myelocele is a formidable list. Now that list doesn't mention heart defects, but it is part of the multiple malformations, and as I said, it's the commonest congenital malformation birth defect. So it's kind of implied in that commentary from 1969. Now, what a lot of people may not understand is that the heart, well, it doesn't look like that heart shape that you see on all the romantic cards. That's not the shape of the heart. And it's actually formed in a very, very complicated way. The cells that form the baby's heart come together from 6 different fields, 6 different areas to form the heart, and there's a complicated choreography which occurs to bring them all together at the right time and the right place. Not only is the heart itself formed in a very complicated way, but the septum, the dividing line between the left and right chambers, is formed in a very complicated way. So we just talk briefly about that. So this is how the baby starts off, just at 18 days. There's the head, there's the tail. Some blood forms like that, and these become blood vessels which start to pulse. These are called the endocardial tubes. They fuse, as you can see here, and then it twists, it rotates to the right, and that forms what eventually becomes the adult heart. And this is where the main vessels from the heart arise, from the aorta and the pulmonary artery. And it's this complicated coming together and twisting. And even at this early stage here, you've got these 6 different fields, cells from these 6 different fields coming together in this super complicated way to form this incredibly complicated organ, which we're still learning about. I have to say, we're still learning important things about the heart. So this is some of the details about the heart that we've talked about, represented diagrammatically. And these are some of the different areas that the heart comes together, these 4 fields, which make these different parts of the heart, which make these different parts of the great vessels, which lead from the heart, these different parts of the left and right atrium, which sit above the ventricles. And this is the atrioventricular valve, the left ventricle, the right ventricle, the common truncus, which becomes the pulmonary artery and the aorta later on, and separates off and matures in this way. So that you can see that these parts of the heart field become the left and right atria, as you can see, and the left and right ventricles, it's all mixed up there, and the common truncus there, which becomes separated there. So it's a very, very complicated dance of cells and organisms. This is about the atrial septum developing. Early on, it's just one common atrial chamber above the ventricles that sort of, if you like, the preamp for the ventricles, which do the main pumping, and the septum primum looks like that. And it's got a hole in it, which is called the first. Is all Latin words. I won't go through it in detail, but there's a gap which forms there, and then it closes the foramen ovale. So this is how the atrial septum itself forms. And you can see this really complicated process. If anything goes wrong in this whole process, you're going to have a hole in the heart, usually at the secundum stage here, not the primum stage. But the point is, both heart development itself and atrial septal development itself are both very, very complicated. Now, the data for the US for atrial septal defect was recently released, and we have charted that and studied it, and we have to publish on this soon. Now, that is the regression line of the first 4 years of this period, and you can see that the rate has pulled away to the top side, to the upside, from the basic regression line, and that pattern persists on a log chart. This is a log chart. Now, the point is that a linear trend on a log chart is actually an exponential trend. So this shows that the rate is growing supra-exponentially, faster than exponential. And if you chart this rate by ethnicity, you find that the leading ethnicity is this is non-Hispanic American Indian Alaskan natives, and the non-Hispanic African American population here, with the other ethnicities there. And these changes persist on the log plot, as you can see. So when we compare the linear model, which is this one, with the green line, which is a generalized additive model, which is a complicated, sophisticated statistical model, you find that the generalized additive model, the GAM, is much more statistically significant. In science, less than 0.05 is considered significant, and this is a little more than 0.01, so it's highly statistically significant. And if we compare the linear model to the quadratic model, it's much more significant. P is now less than 0.01 there, as you can see. So that's just highlighting these trends in this graph here.
Okay, so can I just go back to that graph? You had 113, so that's 1 in every 100 births.
These numbers are per 10,000, so that's one in every 100. Yeah,
that's a lot. Okay, anyway, it's staggering to begin with.
Yeah, and that's the average nationwide.
Yes.
So this is a mixed effects model of ethnicity, which just shows that the non-Hispanic American Indian Alaskan Native non-Hispanic African Americans and the Hispanics, sorry, not the Hispanics, are growing faster than the other four groups. The control here is the non-Hispanic, Asians, and Pacific Islanders. And here you can see it's 10 to the minus 10, 10 to the minus 13. So there's no question that these ethnicities have a higher rate of atrial septal defect than the others. And this is a survey GLM, generalized linear regression model, which again is highly significant. And that's 10 to the minus 18 there, 10 to the minus 20 there, 10 to the minus 58 there. So there's no question that some of these ethnicities are much higher.
So high certainty on that.
Yeah, that's right. So this is the E values, the expected values, and the relative rates. So this is the E value estimate in these things, these ethnicities. They're all more than 1.25, as you can see, and the lower bounds are all more than 4 of them are more than 1.25.
And so that's causality for those that haven't watched the previous episodes.
That's right. Now this is the data by state. This is the overall data by state. Now you mentioned at the national level it's up to 1 in 100, but in Nevada here it's almost 1 in 10.
That's absolutely obscene.
Yeah. So that's and if you look, it's growing really, really fast. And if you look, this is the same thing by ethnicities, and we don't have a key because there's 2 meters, 276 lines. But the point is, some of these ethnicities are bouncing up and down all over the shop. Now, these, you can say they're unstable because the denominator is small for some of these ethnic groups in some of these states, but they're averaged over 5 years, and they're published by essentially the National Birth Defects Prevention Network, which is affiliated and subsidized by the CDC at Atlanta, Georgia. So there's 2,200 data points here in 276 ethnicities, and some of these are very, very high. Now, and you can see that in Nevada, this is now an exponential plot. This is a log plot. So in Nevada, it's growing faster than exponential, and in Mexico, it's growing faster than exponential. So some of these places is growing faster than exponential, and that helps you deconvolute that.
Oh.
So this is a panel plot across the US with each state at approximately its position. Nevada has been removed because it squashes everything else, and you can see that some of the states like Kentucky and Mississippi and Alaska and Vermont are real standouts to the general trend. And this is just charting the states. Each scale here, these scales are different from panel to panel. So they're not directly comparable, but it just shows you what's going on state by state. And there's so many states that you have to put it on 2 plots. Now, this is Nevada, which is the front runner. And this is when the records started in Nevada, 2004, 2008. Now, 2016, 2020, period, and that represents a rise of 595 over 41, which is a 14-fold rise. And you add all those ethnicities together, the mean is a 12-fold rise, the median is a 12-fold rise, and the standard error is 0.085. So there's been a 12-fold rise in Nevada across that period, really accounting for all ethnicities. And the front runner here is actually the non-Hispanic, Asian, Pacific Islanders, which is the highest and also growing the fastest. Now, that's the opposite of the national pattern, because the non-Hispanic, Asian, Pacific Islanders is the lowest group nationally, but in Nevada, they've surged to the front in recent times. And this shows that overwhelmingly there's been a rise, a statistically significant rise. So this is New York. Now, New York's important because it's culturally determinative and financially determinative for the US and the world. And you can see here there's been a 6-fold rise in New York, and overall from, what's that, about 75 to 150. So it's doubled just in 4 years, but it's gone up 6-fold, you can see, across the whole period of record keeping from 1997. And that rise is significant there, as you can see. And that's just giving the numbers in 2014, 2018. Now, it also affects the Department of Defense. So it's also seen in the Department of Defence where there's been a 2.5 to 2.3-fold mean median rise across that period. And that's important because that affects defence readiness. And see, this is a log plot, so that's the linear trend, and you can see that in all these cases it's rising at above the linear trend in the Defence Department. And, you mentioned before 114, this is 165, so 172 there. So very important. Now, Kentucky's a front runner too, 568 in Kentucky. And there's a real story about Kentucky because that was one of the first states to jump on the US Farm Act, which for a large part was about rerouting the tobacco farmers and turning them into cannabis farmers. And that was led by Senator Mitch McConnell, who at the time was the US Majority Leader in the Senate. And his home state of Kentucky was one of the first to adopt it. But
he was previous. Anyway.
Yeah, that's been documented in the published literature. So I'm not saying anything personal there. I'm just quoting published literature.
Yeah.
But as you can see, there's this dramatic rise from, this is 30 to nearly 570 there from 1995, 99, 2016, 16. So that's a massive rise in Kentucky. This is Mississippi, again, an impressive rise. Colorado seems to have gone up and down in some ethnicities, but again, substantial changes. Tennessee has risen. Alaska has risen. We've talked about Alaska before. Mississippi has risen dramatically, particularly in the non-Hispanic American Indian Alaskan Native group. That's much higher than the other ethnicities. That's Missouri, which is high. That's New Mexico, which has just gone up incredibly, but a lot of the data is missing for New Mexico. There's just data doesn't exist apparently. Oregon, the data, the rates are high and fairly flat, but some states are low. Florida is relatively low, or was relatively low until recently. Utah, this is only 40, so Utah is very low, very conservative in Utah. Texas was low, is coming up. Georgia is generally low, conservative south. Maryland is very low. It's so low you have to wonder if those numbers are correct. Minnesota is very low. Iowa is also very low. So it's 20 and 30 compared to some of the numbers we've seen. South Carolina, 18. New Jersey is much lower than nearby New York. So that's, I thought that was interesting just to look at some of the states as single plots, because we've presented it before in the panel plots, but it's all a bit much. Now, the question is, what could be driving this epidemic? And alcohol abuse is falling. Analgesic abuse is falling. Binge alcohol hasn't changed much. Cigarettes haven't changed much. Cocaine really hasn't changed much. But cannabis, last month cannabis use has almost doubled over this period. And this is the different cannabinoids. There's delta THC, delta 9 THC there, and all the different cannabinoids are listed there. This is high potency THC in Department Drug Enforcement Agency seizures, and that's obviously risen dramatically. That's cannabis monthly, cannabis use monthly. And if you multiply the delta 9 THC, the high potency THC and the cannabis monthly together, you get a dramatic rise, which looks like that. And it's, I've done that here. There's the delta 9 THC, the high potency, the cannabis, last month cannabis. And this product, the triple product, which in 2009 was 1,500 and 2018 was over 10,000. So it's gone up sixfold. And this is really the exposure to THC of the community. It's an index. And here's the data presented nicely. See, 1,500 to 10,000 in that 9-year period. So this is the ASD rate by the various substances. This is a linear plot. And you can see that for cigarettes, it goes up. For alcohol, alcoholism, binge alcohol, it goes down. Analgesics pretty flat, cocaine pretty flat, median income is inversely related. But then those two metrics of cannabis goes up. Now, cigarettes has got a positive relationship. See there, more cigarettes is more atrial septal defect, but it can't be cigarettes driving it because the overall rate of cigarettes is declining. So the declining rate of cigarettes cannot be driving a rising rate of atrial septal defect. And the only other option here is these different indices of cannabis exposure. So this suggests, just on a bivariate analysis, that cannabis wants closer looking at. And in this graph, what we've done is two things. We've looked at the slope of the atrial septal defect by time and atrial septal defect by cannabis exposure, and we've plotted those two slopes against each other. In other words, the slope of the line with time and the slope of the line with cannabis basically falls on a straight line. Very, very tight straight line. The other thing we showed is we also charted here the changing legal status of cannabis. And as you can see, that's 2012, 2014, 2016, 2018, is that it's becoming legal. A lot of these high ones that were low and illegal there are now in the legal group up here, or the medical group. So that this high end of the curve is actually dominated by the legal and medical status. And this association is so tight of these two slopes, the time slope and the slope with cannabis, it's significant at 10 to the minus 18. And this is just crunching the numbers. You can actually see the raw numbers there. So this is again the slope, which is really stunningly correlated. Now this is the raw correlation, the atrial septal defect rate in the cannabis. The raw correlation is 5 in a million. So it's 5 by 10 to the minus 12, and that's actually the numbers. So I'm not fudging anything. So the difference. So what we've done here is we looked at high cannabis states and low cannabis states, and this is the raw data, and this is the log data. And the p-value to say that the high cannabis rate is different to the low value is actually 0. So we can say with very high degree of certainty that there is no chance that this difference from the high cannabis states to the low cannabis states has occurred by chance. Well, the question is, what happens with a multivariate adjustment for everything else? So we talked about mixed effects regression earlier, and when we do that, you got very high levels of statistical significance, and in a fully adjusted model, cannabis is still 10 to the minus 10, highly significant. And this is interactive model, and some of these cannabis interactions are highly significant, 10 to the minus 122, as you can see. Survey generalized linear model is another powerful technique we can use. Same pattern there, very highly significant across all adjustments, fully adjusted. Generalized additive model, fully adjusted. So this is last month cannabis in a generalized additive model. And there's two things here. It's highly significantly associated, but the cannabis accounts for basically 90% of the variance of the whole model, just one covariate. So that suggests that this is a very powerful covariate, predictor covariate. When we put delta 9 THC in, the p-value is off the Richter scale, and when you do a tidy thing, it's actually 0. The p-value is 0. And again, 88% of the variance is explained by the model. If you put monthly cannabis and delta 9 THC, 92% of the variance is explained, and p-value is again 0. And I was interested in this generalized additive model where you put these two together and you get 92% explained of the variance, which is what we just saw. So with all the GAM models, all the generalized additive models, again, P is highly significant. And after full adjustment, you can see here that the terms for cannabis are very highly significant. And when we do the legal status, this is looking at the legal status of cannabis across the US. This is by decriminalized, illegal. So the illegal states are dropping. Obviously, it's being decriminalized, changing status, legal status, medical cannabis. And when you dichotomize that into illegal and liberal states, so that the illegal ones are dropping and the liberal states are rising, so you have this dichotomization in that way. And when you look at the states, there aren't many decriminalized, so you just count them in with the medical. you see there's a clear progression. Now, this is a box plot. On this box plot, where the notches, these are called notches, where the notches don't overlap, that signifies statistical significance. So you can see the legal status is much higher than the other two. And when you dichotomize it into legal and not legal, the p-value here is 10 to the minus 13. And the p-value for the trend overall is also 10 to the minus 13. So, and you can see there's a big difference in the mean rate from 67 in the illegal states to 190 in the legal states. And the chi-squared for trend there is 0.0023. So it's a significant trend as cannabis becomes more legal. And then by legal status, that's just showing the trend we just talked about and the means that we just talked about. That's what the raw data looks like. Now, as I said, Nevada with the non-Hispanic Asians and Pacific Islanders is the front runner in all of this. And this is the curve we looked at earlier, and you can see why it's 884. That's almost 1 in 10 babies in Nevada in this ethnicity has this hole in the heart problem. And when we look with a mixed effects model, survey GLM, polynomial, this is a quintic or polynomial quadratic function, you can see the p-values are highly significant in all these models after complete adjustment for income, race, and everything else. Now you can do projections, models into the future. So we've got observed, which is sort of over plotted by the others. You can see it down here on the log plot. The quintic exponential, and there's a super exponential function there, which is an exponential function of an exponential function. And this is the observed values here, and you find that probably the quintic is reproducing the figures better than the others. And the quintic curve, the fifth order polynomial, actually has the lowest, this is called an AIC, Aki-Aki, information criteria, actually has the highest predictive value. And what that shows, at least in the exponential model, is that the doubling time of this epidemic in the last 4-year period, because it's gone from 367 to 884, that's the observed data. That gives a doubling time of 2.8 years. So it's less than 3 years, the rate is doubling.
That is staggering.
Right? And from that, and it says 2.8 years down here's the calculation. And so from that, you can work out the quintic model, the date at which you're going to hit 100%. All the babies are going to have a hole in the heart because you can't exceed 100% because there's only 100% of babies. And so you work out for the exponential model, it's the 6th of August, 2028. And for the quintic August, it's the 19th of January, 2031, sorry. So you can actually work out the date at which these models predict you're going to cross the 10,000 to 10,000 line. And this is just working out the dates. This is how you can see the whole thing. Now, when you go to the E values from all these different models, you find there's 39 E values there. 36% are in the very high group. 77% are in the moderately high group. There, and 100% are in the causal range.
And for those who haven't watched the previous episodes, E-values is causality.
Yep, that's right. And I was very impressed. I just came across this. Minnesota is one of the states which featured in the high ASD rate group. This came across this photograph from the Wall Street Journal, which I just sort of put in. This grey stuff here is the flower, the flower that they harvest is the cannabis flower. This is how Missouri became a cannabis mecca, Wall Street Journal, there's the URL. And this is literally factory-like production, which people may not understand. And you can see why, if this is what happened in Kentucky, why this sort of thing, or in Kentucky it might have been broadacre farming, but in Minnesota it's taken off. And if this sort of thing is going on in Minnesota, then the question has to be, is this linked with this exponentiating or supra-exponentiating epidemic? So that's what I mean in some of my talks. We talk about, we normally think of cancer and birth defects as being rare outcomes of genotoxicity due to any intoxicant. But as the penetrance of this stuff in the community increases, the atrial septal defect data shows clearly that this stuff can go from being rare to being very common in just a few short years. It's actually moving in many places, moving faster than exponential, with a doubling time of less than 4 years in the fastest growing group. So, and the other thing is that this is we believe this is a bellwether index because it's measured. See, aging is biological aging or epigenetic aging is not measured widely in the population. It's just a research technique. But atrial septal defect, of course, is babies are screened for that. So that's the significance. This is a cannabis gene toxicity gone from rare to common virtually in no time flat. And so we're extremely concerned about this, extremely concerned about a lot of the things that we've just presented. And this talk has been more technical. There's been more numbers in it than some of our other talks. But I wanted to make it plain that I'm not plucking these data out of thin air. As I said in the opening slide, this material is generated by one of the most reputable R Studio, most reputable and widely used number crunching statistical programs, heavy duty statistical programs in the world. So I wanted to be very clear. I haven't just pulled these numbers out of the air. I've actually showed the computations, actually the on-screen output from the screenshots that validate really every comment that I made here.
Stuart, you've been running some new data on this topic, and can you just give us the results of that?
Yeah, sure. Let me just share these slides with you. This is the powerful number crunching program that we've used to prepare it. And this is comparing the states where cannabis is legal and the states where it's not legal. It's a pretty complicated slide. It's a bit data heavy, but it shows there are lots of differences between the legal and the states where it's not legal. Cannabis is not legal, but the biggest differences, as you can see here, relate to indices of cannabis use. So that's another subject. Now, this is what we've been doing is looking at atrial septal defect in a space-time analysis. So this is a series of plots from 2005 to 2018 of the ASD, atrial septal defect rate across the states. And you can see that some of these states are high. Nevada, New Mexico, Missouri, Kentucky, Tennessee, and Michigan to a lesser extent there in 2018. So that's the time course of the official CDC-linked data across that period. Now then, if we look at, this is a last month cannabis use. This is a plot of that. And you can see just as the ASD seemed to get more common in these states, so the cannabis use got more common in a lot of these same states. So in the Northeast, that's Maine, New Hampshire, Vermont, Massachusetts, Michigan there, New Mexico, Nevada, Colorado, of course, Oregon, California, and Alaska, where the cannabis is high. And then this is actually a bivariate plot. So in this plot, where both cannabis and atrial septal defect are high, it's pink or purple, and where they're both low, it's green. And you can see across the time period that the map generally went from mostly green. There's a lot of pinks here and purples as both covariates became more common. But the plot is dominated by the very, very high signal in Nevada. As we said the other day, the atrial septal defect rate in Nevada rose to nearly 1 in 10. It's almost 900 per 10,000 births, to almost 1 in 10. And so that dominates the plot. So we want to plot it again, taking that high Nevada signal out for 2014, 2018, they're the highest rates, and then rescaling appropriately. And when we do that, we see this pink signal is now in Oregon and Alaska, somewhat in Michigan and New Mexico, and but there's a different pattern here. This is very interesting in the Midwest. See, we have Kentucky, Tennessee, Missouri, Louisiana down here. There's Michigan is pink. New York State there is brown, so it's up here on the color plane. But there's actually two trends going here. One is where both covariates are high in Colorado, New Mexico, Alaska, and Oregon, and Vermont, and probably Michigan. And another one here in Kentucky, Tennessee, and Missouri, perhaps West Virginia and Louisiana, where it's not going up with smoked cannabis. Because remember, this is an index of smoked cannabis from the National Survey. But there are massive cannabis farms in these states in the Midwest. So the question becomes if the study overall confirms the overwhelming signal that links cannabis with atrial septal defect that's been seen in 6 other places, 6 other studies, recent large population-wide studies. But these here states are clearly an exception. So the question becomes, are these states getting their cannabis exposure not from smoked cannabis, but from environmental contamination from these giant cannabis farms that grow in these areas? Now, this graph is a different graph. This is looking at a bivariate plot of cannabis legal status, where it's a semi-quantitative plot, where cannabis legal is scoring high, and the other legal statuses, decriminalized, medical, and illegal, have been scored appropriately. And you can see that if you do that, then you can almost regenerate this plot here with cannabis legal status. Now, it's well established in the literature that as cannabis becomes more legal, its use becomes more common. People use more of it. They use it more often. There's a higher concentration. So it's not surprising that the cannabis legal status actually replicates the plot of cannabis use that we saw there. But it does implicate cannabis legalization directly in the supra-exponential atrial septal defect epidemic. And here you can see the p-value of that relationship is less than 0.05, it's 0.0057. So let's just go through this in a little more detail. We looked at this graph earlier. Now, this is a univariate graph of cigarette use, right? And what that shows is tobacco use, cigarette use has become less common in the US. So this shows that across the period, cannabis use has become less common across the country. It's still a bit high in Kentucky and West Virginia, but in general it's declined. So it can't be cigarettes that's driving atrial septal defect because it's becoming less common.
Mm-hmm.
When we look at alcohol use in the last month, that's sort of fluctuated up and down, but it hasn't changed much. And you couldn't say, looking at that's driven the atrial septal defect epidemic. This is binge alcohol, similar there. It's much of a muchness. It's changed a bit. It seems to go down a bit there, but overall it hasn't changed much. That's alcoholism. Abuse or dependent on alcoholism is the variable from SAMHSA, the National Survey of Drug Use and Health. So this is alcoholism, and alcoholism has clearly declined across the US over this time, except in Colorado, as a standout there, isn't it? But alcoholism's declined. So you can't say that alcoholism or problem drinking is driving atrial septal defect just on space-time criteria looking at it. Analgesic abuse on this parameter has declined across the US in the way shown there, so that's not driving it. And there's cocaine. Now, cocaine's interesting. In general, it's decreased across the country, but remember, it's only at very low use. It's only about 1% of the population using it, so it's obviously can't possibly drive the ASD epidemic because it's too low. But in the most recent years, in all these cannabis liberal states, cocaine's become more common. And that probably reflects the covariance cannabis gateway effect and the covariance of cannabis use with cocaine. But remember, even though there's this uptick from 2014, 2018, it still can't be driving because you're still only maxing at about 1%. Unlike cannabis, which is up to, I think it's 12 or 13% across the whole country now. Then when you come to cannabis, you see a very different pattern. Overall, it's risen, as we know. Cannabis use has increased across the US, especially in recent years. And this pattern, as we saw before, closely mimics the atrial septal defect pattern we looked at earlier. Now, this is looking at a bivariate plot now for atrial septal defect and cigarette use in the last month. And you can see Kentucky's got a pink symbol there, but in general, it kind of went up, got a bit pink or purple there, but then fell down again. So there's not producing the bivariate high signal with lots of pinks and purples that we saw with the cannabis plot. So this is abuse or dependence on alcohol. So this is alcohol dependence. And you can see the pattern there is nondescript. Again, Colorado is high, fits with the gateway effect of cannabis, but you couldn't say that's driving the ASD epidemic just looking at it. Analgesics, again, is a pretty nondescript pattern with analgesics. Cocaine, again, nondescript. Recent uptick with cocaine in Oregon and Colorado, as we said, probably, and Vermont, probably from the gateway effect of cannabis and co-abuse in high-risk populations. Then this is the cannabis atrial septal defect map we looked at. That's the map we looked at where we take out Nevada, and we see all these pinks and purples here on the western side of the country, and including Vermont. Now, this is the cannabis legal status. This is the cannabis, the map. This is a univariate plot of cannabis by legal status, as you can see here, which looks like that. So when you come to the bivariate plot, you can see how those two things overlook, and you get all these pink and purple signals here, which is what drives the positive results in the analysis. So we did this is forming the geospatial links. This is how we network across the country mathematically. And we do these regressions, which are interesting. And what it shows is that when you regress the atrial septal defect rate against last month cannabis use, the result is highly significant. That's 3 by 10 to the minus 6. And the estimate is quite high. That's a log parameter there. So that estimate's quite high. And when you look at the ethnic cannabis exposure, which you can calculate again, it's a positive coefficient, it's quite positive. When you put all the drugs together, only the cannabis remains in the final model. All the others fall out of the model, as you can see there. And when you put income in as well, everything else is deleted from the model, and the only significant term at the end of the after model reduction is cannabis. Then when you put the cannabinoids in, you find THC, CBD, and CBG. You find THC, CBD, all three, this is an additive model, remain in the final model, and the coefficients for THC and CBD are positive. When you have an interaction between cigarettes and cannabis, only the cannabis term is positive, as you can see. When you have an interaction with the three cannabinoids, cannabidiol and cannabigerol are positive, and the cannabidiol-cannabigerol interaction is positive. And when you include an extra interaction between cigarettes and the cannabinoids, again, you have the same thing fall out the bottom. The cigarettes falls out of the model completely, and just these cannabinoids are positive in the final model. So then we can look at status. This graph is not terribly clear, this data, but if you look at it carefully, this is the mean of the atrial septal defect rate by status. That's the log. If you look at the not log data, the mean in the legal states is 207, and the illegal states is 59, and decrim states is 55, and the medical states is 73. So there's the gradient from 55 and 59 at the bottom.
It's a very marked difference, that's for sure.
Yeah, and this is looking at the median, standard deviation, and standard error of those. And the standard errors are very tight, so these are very different. So the p-value for that overall is 0.02, which is less than 5. And when you dichotomize by legal versus illegal, again, legal is 207 and the not legal is 61. So the p-value for that as a log is 0.025. And when you look at it, this is a 2x2 table. The increased odds ratio is about threefold. See, 2.92, confidence interval 2.85 to 2.99. So it's nearly 3 times higher in the legal state. So this is a space-time regression by legal status, atrial septal defect by legal status. It's highly significant, 0.0058. This is dichotomized legal status, 0.007. And then this is when you add in the last month cannabis use to the legal status, then that knocks the legal status out. The final regression is just last month cannabis. So in other words, effective legal status is related to cannabis. And that persists in the final model, a high level of statistical significance. And when you have an interaction there, again, the last month cannabis use is the last remaining term when you have the same model at the bottom. So this is looking at relative risk. This is 3.8 relative risks. confidence interval there, 1.4 to 9, e-values of 7 and 2.3. Remember we said that more than 1.25 was causal. That's by status. And then by dichotomized legal status, it's 0.006 is the p-value, and the e-values are 6.2 and 2.15 is the lower e-value.
So the causality is getting up towards that magic 9.
Yeah,
Tied lung cancer to cigarettes.
That's right. So in both cases, so here we have legal. This is the model of legal cannabis and ethnic cannabis with an additive model and an interactive model, which both reduce to this final model, which we talked about, that p-value. And the e-value for that is 13, which is higher than 9. And with 5.6 as the lower 95% confidence bound. The relative rate here is 6.99. It's about 7 relative risk, and with a confidence interval from 3 to 15. But the e-value is 13, which is above 9.
Just clarify for us, Stuart, ethnic cannabis, is that non-Caucasian?
Ethnic,
or what they would call non-white, I think, over there.
Is the amount of cannabis used by the different ethnicities is a bit different. So there are mathematical ways we can control for that and estimate that, which is what we've done there.
Okay.
So that's with ethnic cannabis as a covariate. And then that's just looking at this is looking at the non-spatial effect. This is dichotomized cannabis legal status. It says that 64% of the cases in the exposed population is due to cannabis. Now the p-value on this here is 0, which means it can't possibly have occurred by chance.
By chance.
This chi-squared value is extremely high. So and the odds ratio is 3 times higher. So this is a very, very powerful effect, and that's there. So this is comparing the medical cannabis with decriminalized and illegal, and even medical cannabis has a higher odds ratio. 19% of the exposed are due to the thing. P-value is 10 to the minus 271. E-value is 1.8 and 1.85, and this is where cannabis is legal. And here we have e-values of 5.2 and 5.1, p-value of 0. So that just proves it hasn't developed by chance. And then we look at all the e-values that we've talked about from all those regressions, and they come out like this. So there's 16 e-values, 11 are more than 9. So that's 68%, 69% are more than 9. All of them are more than 1.25, which is the cutoff for causality. And of the lower rebounds, 25% are more than 9. And all of them are more than 1.25. So that becomes a strong argument for causality. So what this proves overall, it becomes a very compelling argument that the space-time analysis strongly supports the causal nature of this link, which has been observed elsewhere, it should be said. Hawaii, Colorado, the US before, Australia with the Northern Rivers area of New South Wales, Europe and the US, and 6 other places this has been identified before. What I think is there's a number of take-home points with this study, but what I think is really happening here, I mean, obviously these are frighteningly high rates of teratogenesis of deformed babies, 1 in 10. What's happening, I think, is this is the exponential genotoxic effect of cannabis surprising everybody. See, people probably expect, we know that the cannabis use across the whole US population has about doubled in the last 10 years or so. So they probably expect to get twice as much damage, right? But if they thought that was pretty harmless to start with, 2 times 0 is 0, so it still is not anything important. What they're not factoring in is there's an exponential dose-response relationship between the amount of cannabis exposure and the amount of and the genotoxic related harms. So you could write the following conclusion about these results. Many important conclusions flow from this study. Data demonstrate that cannabis is driving the current exponentiating US atrial septal defect epidemic, which is rising to extremely high levels, approaching almost 1 in 10 births, driven by the known exponential genotoxic dose-response curve. It's known, but it's forgotten, and it's not factored in public health, but its implications in public health are profound, as we've seen. Atrial septal defects gone from relatively rare to extremely common in just a handful of years. Exorbitant cannabis-driven atrial septal defect rates is a clear example of intergenerational teratogenicity, and thus transgenerational transmission of genotoxic effects, presumably acting on both the genome and epigenome. Results fulfill criteria for causality at once mechanistically and statistically and conceptually, since only cannabis is related across space and time with atrial septal defect rates, but not other covariates, as we saw by looking at the maps, right? Space-time concurrence largely implicates causal relationships in itself. The fact that cannabis and ASD are co-varying coherently across space and time together is strong evidence for that the causal nature of the relationship. Findings cannot be explained by extraneous confounding because the E-values are far too high. Several cannabinoids are involved, including cannabidiol, delta-9 THC, and cannabigerol, consistent with cannabinoid genotoxicity being a class effect across all cannabinoid species. This is a class effect across all the cannabinoids. It seems likely that present findings relating to ASD apply similarly to other congenital anomalies and suggest a broader modern renaissance of cannabinoid teratogenesis accompanying the resurgence of cannabis use. In other words, because they don't treat these babies by early abortions, the ASD rates are likely telling something about the pattern of cannabis teratogenesis more broadly, because most of the other serious defects get aborted, so they never get counted because they're never live births. They don't become live births, they don't get counted, so they fly under the radar. So what we're seeing with ASD is probably a canary in the coal mine for what's going right across the spectrum of cannabis-related congenital anomalies. Concerningly, findings in several Midwest states do not accord with local cannabis smoking trends, but may relate to large cannabis crops grown in these vicinities, thereby potentially implicating food chain and environmental contamination. If it's getting in the food chain environment from the hundreds of acres or hectares sowed to cannabis, then it's getting in the food chain. It's not telling people. It's removing their rights to know. It's removing their rights not to be exposed, especially if they're allergic or pregnant or they've got little babies. Overall, the findings strongly indicate that communities need to carefully limit both voluntary and environmental cannabinoid exposure to protect the hearts, genomes, and epigenomes of multiple coming generations.
Stuart, I mean, it's absolutely alarming, but maybe it's a kind of fitting into our little Drug-Free Australia series, is that maybe there is more to come when it comes on cannabis, and it's not looking too pretty. So thanks for your time. Really appreciate you, giving out so much information in our series of 8.
Thanks so much for having me, Gary, and thanks for your attention.